get equivalent to the area of the rectangle here. And then, maintaining the same width. So for example, the total diameter there would be like 8 centimeters, which means this distance here to here, it has to also be 8. What I want to figure out is, what is the height of that rectangle? Okay, so that's what you're going to be doing today when you're solving problems related to area under the curve, and specifically to average y value. So in this case, what we're doing is we're taking a circle and we're going to get the average height of a rectangle if it holds the same area. So in this case, the first thing you would have to do is area equals pi r squared, pi times by 4 squared, which is 16 pi. Now pi is about 3, and 16 times 3 is about 48, but it's actually 3.14, so it's closer to 50. Well, let's use our calculator to make sure we can get that. Calculator, if you don't have the black calculator, I would actually encourage you to use it. So it's 16, this is Desmos Scientific, by the way, which is free, times by pi. And, there it is, right there above tan. 16 times pi is 50.26, okay, 50.27. So we're going to go back to this. So about 50.3. Okay, that's the area. So that means if this area is 50.3, this area is 50.3. And I know that if I multiply this 8 by that distance, I'm going to get 50.3. Okay, so width times height, I guess, really is what it is in this case, or base and height. So what do I multiply 8 by to get 50.3? Well, another way to do that, of course, is to go, I'll call this height. This height would be 50.3 divided by 8. 8 times 6 is 48. So it's about 8.25, 8.27. I'm just guessing about we'll round it to 8.3. Okay, so that height would be, is that possible? Oh, no, Mr. Long. 6 times 8 is 48, about 6.25. That's more like it. 6 times 8 is 48, so about 6.3, we'll say. Okay, is the height. Okay, 50.3 divided by 8. I'm just estimating that. Okay, so I think that gives you an idea of how we're going to calculate areas and how we're going to use it to get the average height or average y value. So we're going to do this with Desmos, okay, with Desmos, and I've already got things put in here for you. So in this question, we want to get the average y value of this graph between 0 and 5. And that represents the hours after midnight, and the y-axis represents the time in degrees Celsius. So in other words, 0 hours after midnight, the temperature is 10 degrees. 5 hours after midnight, the temperature has come down to about, well, if you look at this, 1, 2, 3, 4 degrees. So it looks like it's about half a degree maybe after midnight. And again, there's a lot more temperatures that are lower rather than higher, right? Lower rather than higher. So the way we're going to do this is we're going to figure out the area under the curve between 0 and 5, because that's when I want to get the average temperature. And I'm going to do that by using calculus, and that's called with an integral. So the way that we're going to do that is on Desmos, and I'm going to give you a link to this. You're going to have your equation. 1/2 to the x. And then here we're going to call this area. Area equals, and then we need to use integral. So I get that under functions, miscellaneous, the integral symbol. And in this case, we're going to go from 0 all the way up to 5, and it's going to be for f at x. So the nice thing here is you're only actually going to have to change, and make sure you put dx. The only thing that you will have to change here is the f at x each time. And you'll have to change the 0 and the 5 potentially as well. Okay, so there you've got your curve. You can see your curve there, and we're going to do the area between 0 and 5. Okay, so let's go back now. And so what we did is we got that area, and it turned out to be, so when I used this, it was about 13.98. And now what I'm going to do is take that area and put it all into a single rectangle and figure out what the average height of that rectangle is. The average height of that rectangle is going to give us the average y value over here on the temperature graph, okay, on the temperature graph. So just as an aside, let's see if this, because it doesn't really look, if you look at all the area here, it really looks to me like this is a lot less, but let's see. So if I was to count these up, I would have 1, 2, 3 whole ones, 4, 5, 6 whole ones, 7 whole ones, 8 whole ones. So that's 8. And then I'm going to make that 9 whole ones there, just say, because that little bit there. And then what have I got here? So that's 9. And then I've got maybe a half a one there. And altogether, that might be a half. So that's 10, I guess. No, 11. And then these ones here, about another, almost another 2. Did I? Oh, and plus these ones. Whoops, a daisy, I forgot those ones. And I've got those ones as well. So 12, 13, yeah, it's about 14, right? About an area of 14. Well, if I go over to here, I know that the width has to be 0 to 5 because I did the area from 0 to 5 here. So I want to get the average y value between 0 and 5. So that means I have to fit in an area of 1398 above the x-axis between 0 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I need another 4 above that in a width of 5. So, so that's going to be, yeah, that's about 2.8, right? It's the average height. And I'm going to go through the calculation with you in a second. If I put that on over here, an average height of 2.8 would be something like right there. Okay, that would be our average y value, y-a-v-g. Okay, the average y value. And you can see it's actually pretty low, right? When it goes from 10 to about 0.5, the average is quite low, 2.8. Let's see how we got that 2.8 though. Okay, let's see how we got it. So I know that the area of this rectangle is base times by height. The base goes from 0 to 5 because that's the horizontal distance I'm measuring the average y value over. So then I know the area. I did the area with my integral. Well, it worked out to being 13.98. What are the units on that? Well, I multiplied the y and the x-axis, so it's degrees Celsius times by hours, so it's Celsius hours, and that equals then base, which is 5 hours, multiplied by the height, and the height is y average. Okay, or sometimes it's f average for f at x. So what do I need to do to isolate for y average? Well, I'm going to divide both sides by 5. So I have 13.98 Celsius hours, that's a weird unit, Celsius hours. Then I divide it by 5 hours. So if I cross out the hours and the hours, I'm left with just Celsius. And it happens to be 2.8 degrees. So that, folks, is the average y value on this graph over here, which I'm just going to erase a bunch of stuff so it's easy to see. That's the average y value on this graph between 0 and 5, okay, the average temperature. So 2.8. So there's 1, 2, and there's 3. So that's our average y value there, y average. Okay, the average y value. All right, so I think you see the process. I use calculus with the equation to get the area under the curve over the right interval from 0 to 5, because the question said 0 to 5. And then I take that area under the curve and I make a single rectangle with the same width as over here, and I figure out the height of it. And if I do that, then I'll get the correct value. Now the nice thing is that I've put, for the first several questions, I've actually put the correct rectangle on here. So you can see the answer. You'll know if your answer is correct right away, because that's 0, that's 1, that's 2, that's 3 up there. So that's definitely about 2.8, right? 2.8, 2.7, 2.9. So once we did the calculation and got 2.8, I think we knew we were correct already. Okay, one more. So This one here is a value of a used car. Okay, a value of a used car. And so in thousands of dollars. So the car was bought used for $6,000. And here's a formula that describes the value of the car. And then what we did is we want to get the average Y value between 2 and 5 years after purchase. Okay, between 2 and 5 years. So what's the average price or value of that car between 2 and 5 years? And again, what do? Well, I replace f at x in Desmos with this formula. And then what I do is I say that the area is equal to this. Right, there's the area, because I'm going between 2 and 5 for x. And that's going to give me an area of 6.78 off Desmos. By the way, how much does it look like it's 6.78? 1, 2, 3, 4, 5. I would say that takes about 1. And then there and there together would be, about 0.8. So that works. Okay, so that's the calculus portion. I get the area under the curve with Desmos. And then I'm going to get the average price. Okay, I know it's somewhere around 2, right? Because the price after 2 years is about 3,400, and the price after 5 years looks like it's about $1,500. Okay, so I know the height of this rectangle, and it has to go between 2 and 5 years. Is 6.7. Sorry, the width goes from 2 to 5, the base, and then the height would be from here to here is Y average. So I'm going to do it this way. I'm going to say that base multiplied by height equals area. The base is 5 minus 2, right? Multiplied by the height. And what's the height? Y average. And that equals the area. The area is 6.78. So I know that 5 minus 2 is 3, so I need to divide both sides by 3. Y average will equal 6.78 divided by 3. Okay, 6.78 divided by 3. If I go to my calculator, it was 6.78 divided by 3 is about 2.3. Okay, 2.3. Y average, about 2.3. Now, that's in thousands of dollars. Okay, thousands of dollars. So that is actually $2,300 is the average value between 2 and 5 years. So if I go across, does that look right? Yeah, it sure does. 2.3 seems just about perfect, okay? So 2.3 is right there on the graph. We can see that, we can verify that we're correct. So when you do your calculations, you're going to know if you're correct or not. Okay, folks, so you're going to do the same thing. The next one you're going to do, it just gives you the equation, and you're going to do the same thing. I've already done some of the calculations for you. If you go to the next one, same thing, except now you're going to have to start putting stuff into Desmos to get that area from 0 to 4. There's a real life one about temperature, and you'll have to pull it out because it's going to be underneath that bar, that fraction bar, if you're on your phone. And I'd really like you to cut and paste all the Desmos calculations that you did, so just like I did in the first couple examples. This one here, you'll end up with a negative number because you can see the temperatures are all negative. And then final questions you're going to work on. These ones have the first one has basically a full solution, or almost a full solution anyway. And these ones are a little more challenging. It's average Y value, but then it's also figuring out the X value to get the average Y value. So a few extra steps there, or one extra step anyway. Okay, folks, so good luck in doing this. Really important idea, average Y value, and a really great application of area under the curve or integral calculus. Good luck.